All right, so 8.3 I think is going to be a shortish, nice-ish section. This section is on determinants, and a determinant is just a number that's associated with a square matrix. To be a square matrix, the matrix has to have the same number of rows as it does columns. So a determinant is not a matrix, it's just a number. That can be computed for every square matrix. And to be a square matrix, you have to have the same number of rows as columns. These are both square matrices on this page, and they have a number called the determinant that's associated with them. These matrices on this page don't represent a system of equations, like x plus y equal to 8 kind of thing, and determinants can be used to solve a system of equations using a method called Cramer's rule. And the whole focus of this section is to teach you how to find the determinant of a square matrix. That's just a number that's associated with a square matrix. It can be positive, it could be negative. And then to expand that, once we are able to find a determinant of a square matrix, to show you how that determinant can be used to solve a system of equations using Cramer's rule. And it was a big deal when I was younger because we didn't have technology, and solving a system of equations using Cramer's rule was a lot nicer than doing the row operations that we did in section 8.2, the 2 or 6 elimination methods to get to an answer. So the two matrices on this page are 2 by 2 matrices, so they're square matrices. What I'm going to do to find out the determinant is I'm going to kind of cross multiply. I'm going to cross multiply down, and I'm going to kind of cross multiply up. And I'm going to subtract those numbers that I get. So the determinant of the problem 2 is going to equal negative 2 times 1, which is a down multiplication, minus 4 times 3, which is the up multiplication. And so it's going to equal negative 2 minus 12. The whole answer, it says find the determinant of the following matrices. The answer to problem 2, the determinant, the number that's associated with this matrix, is going to be negative 14. That's not particularly hard to do by hand, but I certainly can do it on my calculator. To do it on my calculator, it's similar to doing the RREF that we did in the last section. So I'll explain this computation on my calculator. On my calculator, first I'm going to have to enter the matrix. And to enter a matrix, you're going to go second, and then the X inverse matrix key. So second, X inverse, and then we're going to go over to edit. And we're going to hit enter when number 1 is highlighted. And we're going to enter the data. We did this a bunch in the last section. So I'm going to enter this matrix, and this is going to be a 2 by 2 matrix, as is yours, because it has row 1 and row 2 and column 1 and column 2, which makes it a 2 by 2 matrix. The rows come first, the columns come second. So I'm going to enter that 2 by 2 matrix. So I hit enter, and then I'm going to type 2, enter, 2, enter, and just enter these -2, 4, 3, and 1. So that I have all 4 entrance numbers in. Then I'm going to hit second, and then the mode quit key to get out of the matrix entering mode. So second and quit. Just like we did, that's exactly the same process that we did in the last section. And the next process is going to be similar too. I'm going to hit second and the X inverse matrix key. And I'm going to go over to math. But this time I don't have to go down anywhere. I'm going to select DET, which means determinant. So my calculator puts me right here, and I'm going to hit enter now. Now that my calculator, I have the matrix in, I'm going to do the math called finding the determinant. So I hit second matrix, arrowed over to math. Now I'm just going to hit enter. And then just like we did in the last section, I needed to get the names here. I'm going to get my calculator to say DET A, because I put this matrix in A. So lastly, I'm going to go second, hit the X inverse matrix key, and I have it in matrix A. I'm just going to have to hit enter twice. Enter first to get the matrix on my main screen. I guess I can close the parentheses if I want to, and then I'm going to hit enter again, and it's going to come back with the number that I computed of -14. For 2 by 2 determinants, it's silly to use your calculator because it takes 5 seconds to do it by hand and 15 seconds to do it by my calculator, maybe 30 seconds on my calculator. When we get to 3 by 3 matrices, they're kind of a nuisance to do by hand, and it'll be nicer to do it on our calculator. So give number 1 a go. When we get to the test, determinants you can use your calculator for if you don't want to do them by hand. It's not something that you're going to, I can think of, you won't see it in another class unless you're a math major, maybe an engineering major. So for number 4, I'm going to do my double cross multiplying and subtracting to find my determinant. So I'm going to cross multiply down and do -4 times 0, and then subtract and cross multiply up and do -1 times 5. This is going to give me 0 minus -5. That double negative turns positive, and my answer is going to be 5. Let me do this on my calculator real quickly just to make sure you understand the steps. So on my calculator, first step, second X inverse key for the matrix, over to edit, hit enter, and then 2 by 2, and then -4, 5, -1, and 0. Have the matrix entered, then second and quit, and then second in matrix again, over to math, hit enter on matrix A, second in matrix a third time, enter, close my parentheses, enter, gives me this lovely number 5. That, again, finding the determinant of a 2 by 2 matrix is so easy to do by hand that I probably wouldn't let my calculator, I wouldn't use my calculator. So there's probably a hiccup in the video because I've done problem 6 wrong twice. So the first time I made a mistake, I'm like, yeah, you made a mistake. Let's just cut that out of the video and do it again and be slow and do it right. And I did it wrong a second time. For some reason this morning, I just can't copy numbers which is an important skill when you're finding the determinants of matrices, is to be able to copy the problem right. Both times I wrote a number wrong, different numbers each time. So let me try to do this again. So in problems 5 and 6, you're going to see square matrices. And square matrices are the only kind of matrices that have determinants. This matrix has 3 rows, row 1, row 2, and row 3. And it has 3 columns, column 1, column 2, and column 3. So this is a 3 by 3 matrix because you do rows first and columns second. And 3 by 3 square matrices that have the same number of rows and columns, are the only kind of matrices that have determinants. Every square matrix has a determinant, but no non-square matrices have determinants. And although matrices can be used to solve systems of equations, this matrix, it would be wrong to throw x's and y's and equals into this matrix because it doesn't represent a system of equations. A matrix that's just generically presented to you usually doesn't represent a system of equations. In fact, the only time a matrix represents a system of equations is if you have a system of equations and you create that matrix to represent it. So I'm going to do the determinant of number 6 by hand, and there's 2 ways to do the matrix of determinant of a 3 by 3 matrix by hand. One is expansion by cofactors, and that's tedious, and we're not going to do enough with determinants to make that method a good one to learn, because it'll take me 25 minutes to show you that, and again, it's not going to benefit you that much. So I'm going to show you the shortcut way to find the determinant of a 3 by 3 matrix. And the shortcut way, I don't know that it has a name, but the shortcut way, you'd start with the original matrix and then you write down the first 2 columns. I'm double, triple checking because each time that I tried to write the matrix down, I wrote one number wrong. And when you write one number wrong, unfortunately, your answer can't be right. So to do the determinant of this matrix, I have to do 6 multiplications, and 3 of them going down and 3 of them going up. Let me do the 3 down multiplications first. The first multiplication I'm going to do is 1 times 2 times negative 5. That's going to give me a negative 10. And then between multiplications that are going in the same direction, I'm going to put plus signs. The second multiplication I'm going to do is 0 times 4 times 2. And 0 in that string makes it a 0. The third multiplication I'm going to do is negative 1 times 7 times 3. That's going to give me a plus negative 21. I need to add these numbers up. I could do that on my calculator and go negative 10 plus 0 plus negative 21, and I get plus negative 21. Negative 10 plus 0 plus negative 21, I get negative 31. It's almost done with just almost half the work. So that's the first set of multiplications I need to do. Now I'm going to do the same thing. Instead of starting in the top corner, I'm going to start in the bottom corner and do 3 more multiplications. So the multiplications that I'm going to do them in a different color just to make them stand out. I'm going to go 2 times 2 times negative 1, which is negative 4, and then 3 times 4 times 1, which is positive 12, and then negative 5 times 7 times 0, which is plus 0. And for these, negative 4 plus 12 plus 0, I think I get 8. So I'm going to go negative 4 plus 12 plus 0, and it looks to me that I get 8. Now I'm going to subtract these 2 numbers. The determinant for this matrix is what you get when you subtract these 2 numbers. So I need to do 6 multiplications, and each 3 multiplications gives me a number. The first number I got was negative 31. The second number I got was 8. And negative 31 minus 8 is going to be the determinant of this matrix. And the answer to problem 6 is the determinant equals negative 39. That's the right answer because I've done this on my calculator. Now let me show you how to do this on your calculator. It's exactly the same as the calculator worked for before, other than we now are going to enter a 3 by 3 matrix. So I'm not going to, the extensions are only for doing it by hand. So on my calculator to do this, second and the X inverse matrix key, arrow over twice to edit, hit enter, and then type 3 by 3 because it's a 3 by 3 matrix, and then 1, 0, negative 1, 7, 2, 4, 2, 3, negative 5. Have the matrix in perfectly, then second and quit, and then second in the X inverse matrix key again, this time over to math. Determinant is selected, so just hit enter. Now get the name in there by going second in the X inverse matrix key again, hitting enter on A, closing the parentheses and hitting enter, and it gives me exactly that answer, so my answer I know is correct. So your 5 should work similarly. I'm going to move down and do 8 just in case you need to have another go at this. So my initial matrix is 3, 4, 1, 2, negative 1, negative 5, 0, 3, 6. I'm going to tack on 3, 4, 1. Look at that. I didn't write this right. I wrote, this should be 4, negative 1. Let me just write these over. So 3, 2, 0, 4, negative 1, 3. I'm having a real issue this morning of copying the problem down correctly. I'm not sure why that is. I'm up, I thought. So anyways, I'm going to add a 3, 4, 1, a 2, negative 1, and negative 5. And I'm going to check 3, 4, 1, 2, negative 1, 5, 0, 3, 6. You've got to, if you don't write the problem down correctly, you just can't get the right answer. So now I'm going to do 3 multiplications down. My down multiplications are going to be 3 times negative 1 times 6, which is negative 18, and 2 times 3 times 1, which is positive 6, and 0 times 4 times negative 5, which is 0. These all are going to combine. Negative 18 plus 6 plus 0 is negative 12. And now I'm going to go to my 3 up multiplications. My 3 up multiplications are 1 times negative 1 times 0, which is 0, and then negative 5 times 3 times 3, that's negative 5 times 3 times 3, that's plus negative 45, and then 6 times 4 times 2, that's 48. These all add up to positive 3. That doesn't do anything, and those have opposite signs, so I subtract them. Now I subtract these 2 results to get the determinant. So in number 8, the determinant is going to be negative 12, which is that number, minus, from the formula, that number. Those have the same signs, so I'm going to add those numbers and keep them negative and get negative 15. I'm going to double check on my calculator real quickly. So second matrix, edit, 3 by 3, 3, 2, 0, 4, negative 1, 3, 1, negative 5, 6. Second matrix, math, DET, second matrix, enter, enter. What I did wrong. Oh, close the parentheses in the wrong spot. Perfect. So I know my answer is right. So we need to be able to compute 2 by 2 determinants and 3 by 3 determinants, and they're not particularly hard. The rest of the section, oh, there's another, I don't know, 20 problems to do, 10 each. involves solving systems of equations using Cramer's rule. So on the test, you're going to be asked to use Cramer's rule. So each one of these problems says solve the systems of equation using Cramer's rule. Cramer's rule involves computing determinants to solve systems of equations, and you always get one more determinant than there's letters. So to use numbers 9 and 10 using Cramer's rule, which is a strategy to use determinants to solve systems of equations, I will need to compute 3 determinants. And I give each determinant a name. To help me understand what they are. And the names are D, D sub x, and D sub y. And they're named really nicely. I didn't make these names up. These are just the names that are standardly given to them. The D just has the coefficients of the x and y. So in this particular problem, the coefficients of the x's are 8 and 2. The coefficients of the y's are implied to be -3 and +1. So my D is going to be 8 and 2 and -3 and 1, and I'm going to find its determinant. Usually, if you're asked to find the determinant of a matrix, you kind of put the matrix in something that looks like an absolute value. If I glanced at a matrix and I saw it in absolute value signs, that means to find the determinant. So the first determinant I'm going to find is D, and to do that, I'm going to multiply down, doing 8 times 1, and getting 8. And I'm going to multiply up, doing 2 times -3, and I'll get -6, and I'll subtract those results. So I'm going to go 8 minus a -6. That double negative goes positive, so I get 14. Let me make sure I haven't messed up by entering this on my calculator as a 2 by 2 matrix. So boom, second matrix, edit, 2 by 2, and then 8, -3, 2, and 1. Second quit. Since I just did the matrix before, determinant of A, and I can just type second and enter, and that line will come back up, and I can quickly find the determinant is 14, rather than going second, matrix, math, determinant, second, matrix, enter. I'll still get the 14. So because I have DETA on the line above, on my calculator right now, if I hit second and enter, my calculator is going to pull that line back up and find the determinant of whatever my new matrix A is. So using Cramer's rule, I need to compute 3 determinants. The first one, D, is the coefficients of the x's and y's. For D sub x, which is the second one, I'm going to change the first column of the D to have the numbers that are to the right of the equal sign. So d sub x tells me to change the x's. So what I'm going to do is I'm going to take those two numbers in the d and change them to those two numbers. So I'm going to take the d determinant and change the 8 and the 2, which are in the x column, to -2 and -4, and I'm going to leave the y column. So the d sub x is you change the x of the d matrix. I'm going to find this determinant by going -2 times 1, which is -2, and -4 times -3, which is 12, and I subtract those. -2 minus 12 is -14. So d sub x equals -14. In the last problem, I got d equal to 14. Let me make sure I haven't messed up. Enter this on my calculator. Second matrix, edit, -2, -4, -3, and 1. Second quit is -14. The last of the three determinants I need to compute is d sub y. And the d sub y, you're not even looking at the d sub x anymore. Let me just cover that page up so we don't see it. D sub y, you change the y column of the D matrix to the numbers that are to the right of the equal sign. So the D matrix, it started off at 8, 2, -3, and 1. The D sub y, I'm supposed to change the numbers in the y column, which are these numbers, to the numbers to the right of the equal sign. So D sub y is going to be 8, 2, -2, and -4. I'm going to find this by determinant by going 8 times -4, going down and getting -32, and then going up, going 2 times -2, and subtracting those amounts. So -32 minus a -4 gives me -28. So I have D sub y equal to -28. So the D matrix is just the coefficients of the x's and y's for this problem. The D sub x matrix, you take the D matrix and you change the x column to the equals column, you leave the y column, find your determinant. The D sub y, you take the D matrix, you take the y column, change it to the numbers to the right of the equal sign, and then do your determinant. So now we've computed three determinants. The three determinants that we've computed, we've gotten D equals to 14. We've gotten D sub x equals to -14. And we did D sub y equals to -28. So Cramer's rule involves computing three determinants, D, D sub x, and D sub y. Once you have those three determinants, you divide to get the values for x. X is going to be the D sub x number divided by the D number because the D's kind of cancel out. Y is going to be the D sub y number divided by the D number because the D's kind of cancel out. So x is going to be D sub x, which is -14, over D, which is 14. That gives me -1. D sub y is going to be -28 over 14, putting D sub y in for the D sub y and D in for D. This gives me -2. My answer is going to be -1, -2. It's a monstrous amount of work, but it works. So my instructions for problem 10 said solve the systems using Cramer's rule. Cramer's rule for this problem involved doing 3 determinants, and then after I found my 3 determinants, 2 divisions. It says check your answer using the RREF feature. So I'm going to make sure my answer is right by entering this matrix using what we learned in the last section. Because what we learned in the last section is how to solve a system of linear equations on our calculator using RREF. Let me check my answer by entering this matrix. That's a 2 by 3 matrix. This has nothing to do with Cramer's rule, but it's a quick way to check. So I enter the matrix, second quit, second matrix math, RREF, second matrix names, enter, and because this says x equal to -1, y equal to -2, I know my answer of -1, -2 is correct. So that's completely optional, this check your answer using the RREF feature on my calculator, but it's almost silly not to check because it's so easy to check. All right, so for number 9, you're going to have to compute 3 different determinants and then do 2 divisions to get the answer. So I'll do 12 just in case what I did isn't enough. So to do number 12 using Cramer's rule involves computing 3 determinants. My first determinant is going to have the coefficient of the x's. I put the straight lines here. The straight lines mean find the determinant. So I'm going to do 5, 1, 2, -7. So D is going to equal 5 times -7, which is -35. That's multiplying down. And then the formula has a minus, and then I multiply up. 1 times 2. This is going to be -35 minus 2. D is going to equal to -37. To do D sub x, I look at the D determinant, which was 5, 1, 2, -7. And to do D sub x, I take the D matrix, or the D determinant, and I change the first column to the numbers in the equal column. So I'm going to put a 1 and 10 in the first column, and I'm not going to change the second column. So my D sub x, I'm going to cross multiply down and go 1 times -7 and get -7. The formula has a subtraction, and I'll multiply up and do 10 times 2, which is 20, really. 5, 1, 2, -7, 1, 10. I'm making sure I'm not making an error because I made so many today. I get this equals to -27. I'm worried about that. Let me get the answer because I already could, D sub x is going to equal that. X is going to be D sub x, so x is going to be D sub x over D, and that would be -27 over -37, which is positive 27 over 37. I'm really worried about that. So let me check real quickly what the answer is by doing RREF. So I'm not comfortable with my arithmetic this morning. So I know I can get the answer to this ahead of time by entering this as a 2 by 3 matrix and doing second matrix math, RREF, second matrix A, enter. Oh, it is an ugly decimal. So x is supposed to be 27 over 37. I haven't made a mistake. I just was so worried that I was making a mistake. So once you have both the dx and the d, you can get the x by dividing dx, -27, divided by d, -37. So kind of done with the x portion of this. Now I'm going to move on to the y portion. For the y portion, I'm going to take the D matrix, which is 5, 1, 2, -7, and I'm going to change from the D matrix, I'm going to change the y column to the numbers in the equal column. So my D sub y is going to be the 5 and 1, and then 1 and 10. And I'm going to cross multiply. I'm going to go 5 times 10, which is 50, minus, and go up 1 times 1, which is 1. 50 minus 1 is 49. So D sub y is 49. So Now I know I can find x, which I've already done, and I could find y. X is going to equal to, I've done it already, I'll do it again. X is d sub x over d. D sub x is negative 27. D is minus 37. The two negatives cancel and become positive. Y is d sub y over d. D sub y is 49. D is minus 37. And I'd probably move that negative up to the numerator, but that's probably all I do for that. So my answer is going to be x equals 27 over 37, y equals minus 49 over 37. Let me do that checking by hand. So I'm done. I've done all the work that I need to do, but the work that I can do is check on my calculator by using RREFA. So RREFA is the best way to check to see if you have the correct solution to a system of linear equations. To do that checking, and it's optional, I would enter the matrix 5, 2, 1, 1, negative 7, 10 as a 2 by 3 matrix and do RREFA, which I did. I'll do it again though. So second matrix, edit, 2 by 3, and then 5, 2, 1, 1, negative 7, 10. Then second, quit. Second matrix, math. Go down to RREF. Then second matrix, names, enter, math, and enter twice to get the fractions. And you'll see x is 27 over 37, y is minus 49 over 37. Okay, so give 11 a go. I'll move on and do 14. So for 14, I need to compute 3 matrices, 3 determinants. The first is going to be D. If I'm solving by Cramer's rule, I create determinants and get one more determinant than letters. So my D determinant, I just take the coefficients of the x's and the y's, and I'm going to find this determinant by going 4 times minus 5 and getting minus 20. And then the formula has a minus sign, and then 3 times 1 going down then up. That's negative 20 minus 3 is minus 23. Done with the D, moving on to the D sub x. To do the D sub x, you look at the D determinant and you change the numbers in the x column to the numbers in the equal column. So I'm going to change from the D determinant, the x column, to have 11 and 37. I'm going to leave the 1 in minus 5. Now I'm going to find that determinant by going cross multiplying up, cross multiplying down, which is 11 times minus 5, which is minus 55, cross multiplying up, preceded by a minus sign, 37 minus 1. That's going to give me minus 55 minus 37. Really afraid to do that. So minus 55 minus 37. I get minus 92. So D sub x is going to be minus 92. D is minus 23. Done with this whole middle bank. Now I need to do D sub y. So I'll look at the D determinant, which is 4, 3, 1, and negative 5. And I'm going to change the numbers in the y column to give me the numbers in the equal column. So I'm going to leave the D determinant's x column, 4 and 3. I'm going to change the y column to 11 and 37. And then I'm going to cross multiply down. 4 times 37, which I'm doing on my calculator off screen, is 148. Then the formula has a minus sign, and I cross multiply up and get 3 times 33. So I'm going to go 148 minus 33 and get 115. So D sub y is going to be 115. So I've done my 3 determinants. Now I need to do my 2 divisions. So x is going to be the D sub x number divided by the D number. The D sub x number is minus 92. The D number is minus 23. So I need to go minus 92 divided by minus 23, and that gives me 4. So that tells me that x equals to 4. And then I need to work up with the y's. Y is going to be the D sub y number divided by the D number. The D sub y number is 115. The D number is minus 23. So I'm going to go 115 divided by minus 23, and I get minus 5. So my answer is going to be x equal to 4, y equal to minus 5. So for number 14, my answer is going to be x equal to 4, y equal to minus 5. I'm going to check by entering this 2 by 3 matrix and doing RREFA. So the checking is optional, but it takes me 35 seconds to check, and it helps. It makes me become more comfortable. So for checking second matrix, edit, 2 enter, 3 enter, 4, 1, 11, 3, negative 5, 37. Second, quit, second matrix math, RREF, second matrix, enter, enter, 4, negative 5, 4, negative 5, perfect. So you should almost never make a mistake if I ask you to solve by Cramer's rule, because you can always just do the check at the end, or at the beginning if you wanted to know what the answer was ahead of time. Okay, one more with, well, there's 3 more that has, maybe I'll do 2 more and then do the nasty big X, Y, and Z's. So to do 16, let me do 15 just to save you some homework. So I'm going to do 15 just because you have too much here. So I need 3 determinants. The first determinant is D, which I pull off the coefficients 3, 2, 2, and negative 1. I multiply 3 times negative 1 and get negative 3. Put a subtraction sign and go up and do 2 times 2, which is 4. And now negative 3 minus 4 equals negative 7. So D is minus 7. Done with the D, moving on to the D sub x. To do the D sub x, you take the D matrix and you change the numbers in the x column to the numbers in the equal column. So I'm going to change this 3, 2 to that 10, 10. No, I'm going to change this 3, 2 to that 11, 5 because I'm not doing number 16. So I'm going to go 11, 5, 2, negative 1, and go 11 times negative 1, which is negative 11, and then minus 5 times 2, which is 10, and negative 11 minus 10 is negative 21, so D sub x is going to be minus 21. Now I'm going to do D sub y, so I'm going to write that D matrix, D determinant down. When you put the absolute value signs, that means to find the determinant. And now I'm going to change the numbers in the y column to the 11, 5. So I'm going to get 3, 2, 11, 5. So once I'm done with the x, I'm no longer looking at the x matrix. I'm only looking at the original problem and the D matrix. And for my D sub y, I'm going to get 3 times 5 cross multiplying down, and then 2 times 11 cross multiplying up. That's 15 minus 22. My D sub y is going to be minus 7. Now I'm going to solve. So I've found my determinants. I know that x is going to be the D sub x number divided by the D. The D sub x number is minus 21. The D number is minus 7. That computes to be 3. And my y is going to be my D sub y number divided by my D. My D sub y number is negative 7. My D number is negative 7. And negative 7 divided by negative 7 is positive 1. So for number 15, your answer should be x equal to 3, y equal to 1. Let me check this to make sure I can get that 3, 1. And again, this is optional. It has nothing to do with how the problem is solved, but it's the quickest way to check. So I'm going to enter this as a 2 by 3 matrix and do RREFA. So on to my calculator, second matrix, edit, 2 by 3, 3, 2, 11, 2, negative 1, 5. Second matrix, math. down to RREF, second matrix, enter, enter. I see 3 and 1, I see 3 and 1, feel good about that. I'm going to do one more with 2 equations and 2 unknowns, and then I'll do a few 3x3s. I usually don't put the 3x3s on the test, so I might not do as many 3x3s. Maybe I'll just do 2 of them, even though the text has 3 of them, 4 of them. So let me do 18, because this is what I always test on. So 18, I need to do the D determinant, which is going to be 6, 2, 2, negative 7, cross multiply down and get negative 42, put my subtraction sign, cross multiply up and get 4, negative 42 minus 4 is negative 46, so D is going to be minus 46. Notice I showed a little bit less, because I can do that multiplication in my head. Now into the D sub x world, I need to have that D right at my fingertips so I know what to change. To do the D sub x, you change the number in the x column of the D matrix to the number in the equal column. Big numbers. So I'm going to go 26, 24, 2, and negative 7. I'm afraid to do this. So 26 times negative 7 is negative 182. And then minus 24 times 2, which is minus 48. So my D sub x is going to equal minus 182 minus 48, and I get minus 230. Wow. Moving on to my D sub y, so I'm going to write down my D again, which is 6, 2, and 2, negative 7. And from the D matrix, I'm going to change the y column to that 26, 24. So I'm going to get 6, 2, 26, 24, cross multiply down. 6 times 24 equals 144. Then a minus sign. And then 2 times 26 is 52. And 144 minus 52 equals 92. So D sub y equals 92. Have all the determinants that I need. So I'm ready to get to my answer right now. X is the D sub x number divided by the D number. The D sub x number is minus 230. The D number is minus 46. So minus 230 divided by minus 46, and I get x equals to 5. I'll move on to the y. The y is the D sub y number divided by the D number. The D sub y number is 92. The D number is minus 46. So 92 divided by minus 46, I get y equals to negative 2. So my answer is going to be x equal to 5, y equal to negative 2. Let me check that. I'm done, but it doesn't hurt to check. It takes me seconds to check. I'm going to check by doing RREF on that 2x3 matrix. So I'm going to enter that. 6, 2, 26, 2, negative 7, 24. Doing the proper math. And I see 5, negative 2. Perfect, my answer is right. So give 17 a go. If you feel good about these, you can skip 19 and 20. Because it's just going to be a tedious mess. We have 4 problems to do with x, y's, and z's. I'm going to do 2 of them. You can just do 2 of them as well. So I'm going to solve by Cramer's rule. You always get one more determinant than letters. To do Cramer's rule for when you have 3 equations and 3 unknowns, you're going to need a D sub x, a D sub y, and then a D sub z. Always one more determinant than letters, and we get them exactly the same way. So for the D, I'm going to pull off the numbers in front of the x's first, which are implied to be 3, negative 1, and 1. And then the numbers in front of the y's, which are negative 2, 1, and negative 1. So when there's not a number written, there's an assumed 1, and you drag its sign along with it. And then the numbers in front of the z's are going to go in my third column, 1, 2, and -4. I'm going to make a vote. On the test for 3x3 determinants, you can use your calculator to do those because they're kind of a nuisance to do by hand. 3, -2, 1. There be at most one 3x3 determinant on the test, so it's not like I'm saving you much room here, but I'm going to do this on my calculator. So let me clear the screen out. Second matrix, edit this as a 3x3 matrix and do 3, -2, 1, -1, 1, 2, 1, -1, -4. 3, -2, 1, -1, 1, 2. Ooh, my eyes are wearing out. 1, -1, 4. Second quit. Second matrix, math, determinant. Second matrix, enter, enter. D is going to be -2. Done with the D. Let me just color code this now for the next one. I'm going to go on to D sub x. To do D sub x, we need to know the D matrix, which I have right above, so I'm not going to write it again. How do I find the D sub x? I take the D column, change it to the equals column. It's exactly the same. So my equals column is going to go where the x is. So I'm going to get 15, -10, and 14. And the rest of the D matrix, -2, 1, -1, and 1, 2, -4, are going to stay the same. So let me figure that out real quickly on my calculator. So I'm going to enter this matrix, second matrix, second matrix. It's a 3x3 matrix. I go over to edit. 15, -2, 1, -10, 1, 2, 14, -1, -4. Double check. 15, -2, 1, -10, 1, 2, 14, -1, -4. Feel good about that. Matrix, math, determinant, second matrix, names, enter. This is -10. Now I'm going to move on to my D sub y, and it might not hurt if I do this better. So my original D matrix, 3, -1, 1, -2, 1, -1, 1, 2, and 4. And from that D matrix, to get D sub y, I need to change the y column to the equals column. So that column's the y column. For my D sub y, I'm going to change that column to the equal column, which is 15, -10, and 14. So on the test for a 3x3 determinant, you can use your calculator because they're just tedious to do by hand. Let me make sure I haven't messed up. I don't think I have. So let me enter this on my calculator and do determinant for it. So on my calculator now, I'm going to enter that. Second matrix, edit. It's a 3x3, then 3, 15, 1, -1, -10, 2, 1, 14, 4. Double check that I have it right. Looks reasonable, so second quit, second matrix math, DET, second matrix names. My D sub y is -118. Wow. Let me double, triple check that. I'm not liking that number. 3, -1, 1, 15, -10, 14, 1, 2, haha. 1, 2, I didn't write the -4. It felt so big. When I copied this down, I got all the way perfect to the end. So that's not the right number because I wrote this number down wrong. So let me fix that by going second matrix, edit, and getting down into this matrix and make that 4 a -4. Now let's try it again. Second matrix, math, determinant, second matrix, names. Now I get that feels so much better because all the numbers were so small. I didn't feel like I should have a number that big. So I'm done with 3 determinants, but I need that fourth. I need that as a D sub z. So I'll pull out another sheet of paper. To do the D sub z, I have to know the D matrix, which was 3, -1, 1, -2, 1, -1, 1, 2, -4, and I have to change the z column to the equal column of 15, negative 10, and 14. So d sub z is going to have 3, negative 1, 1, negative 2, 1, negative 1, and then 15, negative 10, and 14. So let's see what that happens. So I'm going to enter that on my calculator. So second matrix, edit, that's a 3 by 3, then 3, negative 2, 15, negative 1, 1, negative 10, 1, negative 1, 14. Make sure you enter it right, because if you enter it wrong, it's going to give you an error. So now second quit, second matrix math, DET, second matrix names, boom, boom. And I get d sub z equal to 4. This is good because I have nice small numbers. So the numbers that I've computed so far, I have d sub d equal to negative 2, d sub x equal to negative 10, d sub y equal to 2, and d sub z equal to 4. Easy enough now, just divide to get each letter. So for each letter now, I'm going to divide. X is going to be d sub x over d. That's going to be negative 10 over negative 2, which is going to be 5. Y is going to be d sub y over d, which is going to be 2 over negative 2, which is negative 1. Z is d sub z over d, which is 4 over negative 2, which is negative 2. For my answer, I'm going to write 5, negative 1, and negative 2. Done, but checking can never hurt. The easiest way to check this is to enter the 3 by 4 matrix that's implied by the initial problem, which would be 3, negative 2, 1, 15, negative 1, 1, 2, negative 10, and then 1, negative 1, negative 4, and 14. I'm going to enter that and do RREFA, and hopefully I get exactly those numbers in the right-hand column. So second matrix, edit. This is a 3 by 4 matrix. This has nothing to do with Cramer's rule. This is just checking to make sure my answer is correct. Let me check. That column's okay. That column's okay. Okay and okay. So now second quit, second matrix math, RREF, second matrix names, 5, negative 1, negative 2. Feel perfect about that. So give 21 a go, and I will do 24 if you're not ready for this yet. And then I think we'll end the section there, even though there's going to be 2 more problems that we're not going to get to. This takes so long, and I won't put them on the test. So let me, off on each sheet of paper, I need to calculate D. I need to calculate D sub X. I need to calculate D sub Y. And I need to compute D sub Z. One at a time. First one I'm going to do is D. So D is going to have the coefficients 4, 4, and 5. And then 4, negative 2, and 3, and then 4, negative 8, and 8. On the test, 3 by 3 determinants. If there's one, do it on your calculator. So this is going to be my D number. So I'm going to enter this second matrix, edit. This is now a 3 by 3 matrix. Make sure you enter it right, because if you enter it wrong, nothing good can happen. I get D, is negative 168. That's not comforting, but hopefully the other numbers are kind of biggish too. So the first work that I got was D is negative 168. I'm going to double check real quickly that I haven't entered that wrong. 4, 4, 4, 4, negative 2, negative 8, 5, 3, 8. It feels right. On to my next sheet of paper. And I'm going to do D sub X. Well, to do D sub X, I have to have the D matrix staring at me, which is 4, 4, 5, 4, negative 2, 3, 4, negative 8, 8. And I'm going to change the numbers in the x column to the numbers in the equal column. So d sub x is going to be 12, negative 12, 21. That's just taking that and changing it and leaving the next two columns. Now I'm going to find d sub x. Enter this on my calculator. So hopefully by now you're really comfortable doing these enterings on your calculator. Double check it. 12, 4, 4, negative 12, negative 2, 8, 21, 3, and 8. Good enough. Second quit. Wow. So I get d sub x is also negative 168. That's good. That means x is going to be 1. So on to my first sheet, I'm going to transfer this. D sub x is also negative 168. I'm going to move on and find d sub y. To do d sub y, I need to have the d determinant, which was 4, 4, 5, 4, negative 2, 3, 4, negative 8, 8. And I need to change the y column to that equal column. So when I go to do d sub y, the first column is going to stay 4, 4, 5. The second column is going to become 12, negative 12, 21. The last column is going to stay 4, negative 8, and 8. So I'm just changing the y column to the equal column. Now I'm going to pull out my calculator. Second matrix, edit, 3 by 3. Four 12 4, 4 negative 12 8, 5 21 8. Second quit. Like if I just hit second and enter, since I just did a determinant, it's going to pull that line back up. It tells me that this is 0. So this is d sub y equals 0. It's not undefined, it's just 0, and that's okay. Surprising, but okay. So for my d sub y, I'm going to write 0. And I'm going to move on to my last determinant. Again, to do d sub z, I need to have the d1 at my fingertips. D is 4, 4, 5, 4, negative 2, 3, 4, negative 8, 8. And I'm going to change, for d sub z, the z column to the numbers in the equal column. So when I go to do d sub z, my first column is going to stay 4, 4, 5. My second column is going to stay 4, negative 2, 3. My last column is going to become 12, negative 12, 21. And I'm going to use my calculator. Enter this as a 3 by 3 determinant. Make sure you enter it right. Then second quit, and I could just hit second and enter because I just did a determinant, and I got negative 336 for d sub z. So d sub z is negative 336. Ready to do my answers now. X is going to be the d sub x number divided by the d. That's negative 168 over negative 168. That must be 1. Y is the d sub y number divided by the d. That's 0 divided by negative 168, which is 0. And z is the d sub z number divided by d, which is negative 336 divided by negative 168. Do that on my calculator. So negative 336 divided by negative 168, and I get 2. So my answer is going to be 102. I'm done. It's completely optional to check. The easiest way to check is doing RREFA. If you don't want to check, you don't have to. But for my checking, I'm going to enter the matrix 4, 4, 4, 12, 4, negative 2, negative 8, negative 12, 5, 3, 8, and 21. It's a 3x4 matrix, and I'll do RREF And I should see in the right-hand column 1, 0, and 2 if I did this right. So second matrix, edit, 3, enter, 4, enter. Feel like that's okay. So second quit, second matrix math, RREF, second matrix names, and I see 102, 102, so I think my work is perfect. So give 23 a go. If you don't feel comfortable doing the 4 determinants and solving the x, y's, and z's, you can do 25 and 27 as well. But if on your homework you stop on 23 in this section, it's completely fine.